Hey, what's up? This is Václav. At the end of October, I posted a short that I'm starting to work on making my espresso machine smart. I had all the parts ready, so I thought I'm gonna get it done in one day, then I'll edit the video and I'll post it within 1 week. But I didn't. I was quiet for more than a month. So what happened? Well, in short, I've been struggling with the project. It was more complicated than I thought initially. Somewhere in the middle of the project, I even thought I'm gonna scrap it out, throw out the machine and buy a new one. At the end, I managed, but I didn't achieve all I wanted. Or did I? Well, the primary objective was to improve the machine to make better coffee and to automate it so that it could make it repeatable with the same quality. And I did achieve that with 100%, or maybe even overachieved. I think the coffee is really great. But I also assumed that I will integrate it with my home assistant, so I can perhaps turn it on remotely in the morning, so it has the right temperature when I come downstairs. And I have not achieved that so far. So let me play the video from the beginning, and I'll try to summarize the result at the end. So today we're going to be looking at my espresso machine. We're going to be making it smart, connecting it to Home Assistant, but mainly we're going to be making it to make a better coffee. Let me elaborate. This is a rather cheap espresso machine, Gaggiuino Classic Pro. The reason I have it and the reason it's popular is it's very manual and it's very easy to tweak. There is lots of mods available for it. In fact, one of those I already have installed. But I will remove it and I will change it to the what I would call ultimate mod that will install microcontroller inside the coffee, and it will control the temperature, the pressure and the flow rate of the coffee. By default, the coffee machine has only a single boiler with a heater that is controlled by a temperature sensor. So you can see the red light in here that it turns on the heater, and when it reaches certain temperature, it'll turn it off and lets the temperature decrease. And when it reaches the low threshold, it'll turn it on again. So the temperature varies from low to the end. So depending when you start your extractions, you might not get the ideal consistent extraction of your coffee. So this is one of the things we're going to be improving. One of the mods that is available for it is a PID controller for the temperature. I don't have that one, but I was looking for it. I'm going to get something better actually. The other thing is the flow rate. It's got a pump that is on off. You turn it on and it'll just run, and then when it's finished it'll turn off. There's no way to control the flow. Now again, there is another mod available. You can variably control the pump, the voltage for the pump, so you can control the flow. You can do things like flow rate profiling. I'm going to explain it in a bit later. So this is one of the things we're going to get as well, but it's not going to be manual. We're going to be controlling it by the microcontroller. So again, we're going to get consistent result. One of the issues with this coffee machine that people complain about is the pressure on the steaming wand, and again, it's caused by the temperature control, because when it reaches the high threshold temperature, it'll turn it off and then the pressure will start decreasing. So depending when you start making your milk, if you are towards the maximum, when it turns off, you might be getting decreasing pressure, and it's the milk making might take a little bit longer time. So I said already, I have one mod already installed, and the one I have is I have installed a different spring from Shades of Coffee into the pressure valve. And the reason I did that is when the coffee machine is delivered, it comes with this portafilter with this pressure basket, I think they call it. It looks like a regular basket, but if you look at it carefully, it looks like there's those little holes, but it has like a double button. Those holes, they don't go through, but there is like only one single hole in the middle, and it creates pressure inside this basket. And the reason why they do that is they designed that for like a consumer grade coffee pre-grinded that you buy in the shop, that is not grinded for the espresso size. and with that basket you could arguably create beverage which is kind of good espresso, average espresso. But I'd like to have something better. One of the good things about the coffee machine is that this portafilter is a standard size, so I can buy them in a regular market. It's the same portafilter that is used in professional coffee machines in your coffee shop. So I bought this standard basket from VST, which is pretty good quality basket, and it's a regular one, so I can grind here. I have this niche coffee grinder and I can grind a regular espresso and use that for the machine. But because it was tuned for this pressure basket, they were set up for very high pressure. So the Shades of Coffee, they sell those different springs that you can open the pressure valve and replace the spring for lower pressure. So I have mine set, I think, to 6.5 bar, and it's making delicious coffee. So I have that in, but it's gonna get out because with this mod we're gonna be making, it's gonna be able to control the pressure through the microcontroller throughout the brewing process. So this is gonna be exciting. It will have a display here on top where you can control it. You can set up different flow rate profiles. Why you wanna do that? So when you're brewing coffee, the taste of the extracted beverage varies throughout the extraction. Typically, in the beginning, it's kind of sourish taste. Throughout the middle, it's nice, sweet coffee. And if you over extract, then it might get a little bit bitter. Through the profiling, you might get a pre-brew in the beginning where it's filling the basket with zero pressure to make sure that the puck is moist, and therefore the extraction is going to be consistent throughout the puck. It's not going to create channeling. And then it's going to increase the pressure initially, and then it's going to keep decreasing towards the end. For example, this is one of my favorite profiles. And through that, you're going to sort of maximize the extraction through the middle, where you have a nice sweet tasting coffee, which might be especially useful for lighted roasts. It's rather complicated. There is lots of things I had to buy on the AliExpress. And when they came, okay, the buying was easy, but now I'll have to assemble it. I also have printed a number of components on the 3D printer, including the top where the display is going to come, but also the boxes for inside where different components are going to get in. So I'm a little bit nervous. This is quite extensive mod, but enough talking. Let's get into it. My first learning was it is not powered by one of the espressive chips, but by STM32, also called Black Pill. So I had to learn something new. It came on the PCB, so first thing I had to do was to solder in the connectors so I could plug it into the socket. Then I had to compile and upload the firmware. Another learning, this is not done through the Arduino, but this is coming through PlatformIO, which is a plugin to Visual Studio Code, and it's uploading through ST-Link. So again, I have learned something new. Uploading the firmware is done from the Visual Studio Code through an extension called PlatformIO. So you have to have this one installed first. I do, so I can head over to it and I can hit compile and upload, right? Well, not so fast. What we need to do first is we have to make sure that we have the right branch selected. There is a number of branches. I have selected the STM32 Black Pill because this is what I have, but I suppose if you use the Arduino Nano, you have to pick one of those, and there are a couple of other branches you might like to test if you know what you're doing. But even if I have the right branch, it's not the end, because in the PlatformIO there is a number of tasks, and you have to select the right task to compile and upload the firmware. There are different options, variations in the configuration, depending on whether you use the octocoupler or the 5-volt relay, whether you're using for the scales single or dual clock configuration. I don't even know why they made such a difference, because based on my checking, both were equally. There is no advantage to one or the other, and the single clock is simpler, so I don't even know why the dual clock exists. But anyhow, it's out there, and then based on the way how you upload it to the microcontroller, either through the DFU or the ST-Link, you have to choose the right task again. So this creates 8 different configurations and you have to choose the right one, otherwise it won't work. And to add the complexity, there is one type of configuration for the PCB. So those 8 were for what they call Lego style configuration, where you buy those individual components and you can wire them together. They also have a configuration where you put all the components on a custom PCB. They don't document it on the website, but you can learn about it somewhere hidden in the Discord. So there is 3 more configuration for that. And to add to this, there are configurations for calibrating the scales. And again, there are options for ST-Link or DFU and for single or dual clock. So lots of different options and you have to choose the right one. So in my case, I'm using the relay single clock ST-Link. So if I open this folder, it will show me the tasks. And what I want to do is I want to build it first and then connect the microcontroller through the ST-Link and hit upload, which will upload the firmware image to my microcontroller finally. So that's done. And I have to do similar thing with the Nextion display, but for those, they're already pre-compiled files in the GitHub page. So I just need to pick up the right one for my model. So in my case, it's Nextion Discovery LCD. I need to download this one, put it on a micro SD card, put it in the display and power it on, and it'll upload it. So with that, we have all the electronics configured and we can start preparing the wires and wiring things together. Then the fun part begin. I had to create all of the wires and connections and connectors, crimp them in and solder them in and interconnect everything, combine the old one with the new one and connect everything. And I thought it's gonna be like a 1-hour project, and I'm gonna put everything on video and then turn it into this very brief how-to tutorial, as I usually do on my channel. So naive I was, and actually ended up with 1 month of work, trial and error, putting things together, disassembling it, starting from scratch, trying to read the documentation again, having endless discussions on the Discord channel. Turns out it's not simple at all. When you go to the documentation section, then we will very quickly learn that what we have just experienced in the PlatformIO, it continues throughout the whole install. It gets even more interesting. In fact, they're having a disclaimer at the very top of the site saying that this is absolutely not exhaustive step-by-step tutorial, and that if you want to do it, you have to apply some magic to it. So in the very beginning, you see there's those 2 major flavors with the Arduino Nano and the STM32 Black Pill, which is the currently supported configuration. But the whole documentation is written primarily for the Arduino Nano. So the way how it's done is it describes how it's done for the Arduino Nano, and then it tries to outline the changes that you have to make if you would like to use STM32 instead. I think it's for the people that in the past used Arduino Nano and then they want to upgrade to STM32, but for someone going straight to STM32, it's not the easiest. The other thing is there is those 2 types of machine, Gaggia Classic and Gaggia Classic Pro, and they're very different in terms of hardware. So that's where it gets very interesting. And even the Classic Pro, there is 2 flavors, one with the Echo and the non-Echo. And I have a suspicion that even for the Echo, there are some differences based on when they produced that. So if you scroll through, there's a timeline where you could, there's some initial checks and steps, and you can go through that, purchase all the parts. They say first, purchase all the parts. I did that. Problem is, I have learned that there were a number of things in the bill of material in here that were dependent on the choices I make later on throughout the install. So I ended up purchasing from AliExpress 3 times, and you kind of wait 3 weeks, at least 1 month for the delivery. So even though I have started pre-ordering that upfront, I ended up purchasing things in the middle. To give you an example, Here they say you have to order the Arduino Nano expansion board. If you read for the STM32 upgrade, there they say you have to make sure that you use the green board, this one, because if you have the blue one, it actually interconnects some of the pins, which for the Nano it's used for the ground, so it connects the ground pins, which kind of makes sense. But for the STM32, there are different pins on those positions, so it interconnects those and it doesn't work. Then there's two power supply options. I chose the one for the 5V 2 ampere PSU, which to me looked much simpler than ordering two parts, going to 12 volts and then step down from 12 down to 5. But throughout the project, I have learned that actually the first option is preferred. It probably provides a little bit more stable voltage. So if I would do it now, I would probably choose the first option, but I went for the second one. But in the illustrations throughout the documentation, it primarily uses the first one, which renders some of the illustrations in the documentation a little bit useless because I don't know what I'm looking at. So this is the base functionality. Then there is extended one, which I went for. So for the dimmer, because I wanted to do the pressure profiling, and then you need a pressure sensor for that as well. And then there are some for the Gaggiuino Classic, but I have a Gaggiuino Classic Pro, so I had to order those instead. Then there is the upgrade pack for the STM32. So once you go through all of that, where you say this is the Arduino Nano, Arduino Nano expansion board, and so on, then you have to kind of apply, instead of some things, or on top of some things, you have to buy the STM32, and here if you click on the link, it will take you to AliExpress, and you need to make sure that from those you use the right one, because there's three options, so you have to use the proper part number. Then there is the analog digital converter for the pressure sensor and the 5V relay, which supersedes the 1-bit optocoupler, which I mentioned previously. And then there are options for the scales. Again, there's version 1, version 2, so you have to choose one and then go through it. And finally, there are links to the files for the 3D printing, and again, you have a number of options and you have to choose the right ones, and some of them are for the Nano and some of them are for the STM32. So in here, I ended up printing some components I end up not using because I didn't know I don't need them. Right, and then there is two sections for the Gaggiuino Classic. I didn't go there, but then you go to the Gaggiuino Classic Pro, and here the fun begins. So in the very beginning, it shows you the Arduino Nano with the expansion board, and as I mentioned before, this is actually superseded by the STM32, but the documentation actually talks about the Arduino Nano. And then it starts. There are different pictures. They're kind of weirdly distorted. And then there are illustrations like that, which I was fighting with. For example, in this picture, I didn't know what I'm looking at. So this turns out to be the power on-off switch, so the one on the very left side of the machine, but for some reason the pin number 1 is on top of the machine and 2 is below that, but here on the illustration it's upside down for some unknown reason. There are numbers on those pins written, but the way how the machine is done, you can't actually see that. You would have to take the switch out. So it's kind of interesting. And I didn't know what those wires are, if there are new ones or the existing ones, where they connect. And then there are those pictures when it's very hard to see what I'm looking at. And once I'm staring at it for 30 minutes or so, then I actually discover that this is not for me, because I probably have the Echo version, which is sold in the EU and UK. And then it probably looks something like that, but look at this mess of wires. I don't know where I'm looking at and what I'm supposed to be looking for. And to add to this story, there is this brewing switch where there's those wires connected. In some further step, further down the line, we're gonna be actually unplugging those and plugging a relay there instead. So in a way, we're looking at documentation for Arduino Nano with some overlay of STM32, and we're looking at the wires, and then we add sort of overlay for the EU UK Echo version, which then we will again overlay with some further change in the future with the relay, which replaced the octocoupler. So this is kind of very difficult. So I can carry on like that. But unfortunately, I wasn't able to record beginning to the end documentary on how I was assembling those things and comment it, because it was very iterative. I did certain thing and then it didn't work. I took part out and then I replaced other thing. And I was working on it for about a month, trying different things. Many of them didn't work. If I wanted to do it for you, I would probably have to put the machine to the original state and do it again now that I know how it's supposed to end up. But I'm afraid I'm not able to put the machine to the original state. So what I'm going to do instead is I'm going to show you the finished state and I'm going to comment and show you where things are, but I'm not going to document the whole process. So let me show you how it looks like when this is finished and working. So when I open the box, on top of it there is a little bit of space where there is the 3D printed box for the electronics. It's printed from a PETG because it could be quite hot in there. And all of those yellow connectors, these are the ones I made. Most of them plug into the switches, but some of them, like this one, I used to bridge the wires that I took out, like this one, which is actually used to bridge the wires from the brew switch that was used for the eco version that automatically turns it off. And for most of those I'm creating sort of a splitter, so I'm dividing the wire into two and I'm plugging the original connector to one piece and then I'm plugging the control unit to the other one. So these are all the wires in here. In the back of a machine, I have connected the solid-state relay, which is connected to the steaming thermostat. A solid-state relay is similar to a regular relay, but there are no moving parts, so that it will work much longer. Then if you look inside, there you can see the thermocouple sticking out of the boiler with a blue cable on it. That one replaced the existing one and connects to the MAX 6675 connected into the electronic box. Now, moving on from the electronics, this thick red hose, this is a new thing as well. There used to be one continuous hose running from the boiler to the coffee machine. And there is this T fitting in the middle that is actually used to connect the pressure sensor that is hidden behind those tubes. I'm trying to get it out, but I'm not sure if you will be able to see that. I have isolated that, and there is a wire coming from there that's also then connected to the control unit. So this is it. So let me now just open the box with the electronics and show you how it looks like inside. So the heart of the whole box is this STM32, which is the microcontroller where it connects all the inputs and outputs. On the right side, there is the power supply. And because all of the components need 5 volt and a ground, I connected that to this circuit board on the right top corner where I connect them. Then on the bottom, there is the MAX 6675 thermocouple. Next to that, there is the dimmer that controls the pump. Next to it is the 5 volt relay that connected instead of the brewing switch, and under all of those cables there is the analog digital converter that is used to measure the pressure. Finally, some of the wires, like from the display or from the low voltage part of the switches, they go directly to the microcontroller. So let me just close the whole box and add the lid on top of it, making sure that the ground wires are connected and the hole goes through to the water tank. So it's secured with only 2 screws, very simple. And on top there is the Nextion display that is housed in the 3D printed top that is just nicely sitting on top of this whole thing. So finally, when I turn the coffee machine, so you can see it from the front, there is a drip tray, and under this drip tray, let me just remove this tube. Under this drip tray, there is this, it's kind of difficult to do it with one hand. there is this 3D printed part with two weight sensors with the scales that is measuring the weight of the beverage. So we're done. Let's make some coffee. 18 grams in. Grind it. Put it in a basket, level it, temp it. Put it in the group head, insert the cup. Now I'm tarring the scales, but apparently I don't have to do that, it's automatic. So as soon as I push the brew button, it'll start a pre-brew for 10 seconds, so it'll wet the puck until the coffee starts pouring from the bottom, and it's gonna wait for 2 seconds, and after that it will start the brewing until the weight reaches 2 times the weight of the coffee. So 2 times 18 is 36 grams, so it'll stop automatically on 36 grams. Here you can nicely see the pressure profiling, which is the blue line on the chart. It was 2 bars for the pre-brew, and then it raised to 9 bars, and it's decreasing to 6 bars toward the end. This is how it's configured. So now the coffee is done. I'm going to clear the showers. I'm going to push the button here and briefly push the brew button, and then push the steam button to start increasing temperature. So in the meantime, I can prepare milk to the pitcher. And then once it indicates that it's ready, I can start steaming the milk. As you can see, the pressure here is much better than from the stock Gaggiuino Classic Pro. It's actually very comfortable to work with. Lots of pressure in here, very comfortable. So when I have enough and the temperature is right, I can stop making the milk. Obviously clean the wand, the milk there to be stacked. And then I can do my crappy latte art. This is my first attempt on this new machine, so not really proud of it. I think the left side is alright, but the right side I screwed up. If you barista, let me know what I've done wrong. So with that, I'll call it a project, at least for now. Overall, I'm quite pleased with the result. It really makes great coffee much better than before. And what's more important is it makes it more consistently. Same coffee every time. But I didn't manage to connect to the Home Assistant. Maybe it was a wrong application from the start. See, the microcontroller starts when you turn the machine on, and what it does is it'll start preparing the machine for making the coffee. So it'll start heating it up. So it takes a lot of power. So it is normally off, so there is no way to connect to it. I can't use it to control the power on switch. So what I'll probably do is I'll try to connect the power on switch to a smart switch, and I'll do it that way. But I'll leave that for the future. Now, would I recommend you to do the project? Well, it depends. First, not everyone cares about experimenting with the coffee. If you just want to push a button and get a beverage, then this one makes no sense. In fact, you probably noticed that I also have this consumer Nespresso machine for these occasions. Now, if you would like to do your espresso manually, then it depends if you also enjoy doing such projects, learning something, solving issues, and then having the feeling at the end that you've overcome all of those and you've done something special. And then third question is if you would like to dedicate all this time to it, because it was not done in one day. I did cross all the 3 check marks, but if you did not, then I'd say just buy a machine that meets your needs. And if you just cross the first check mark but not the other 2, then yeah, it could be a little bit more expensive. So I'll leave you with that, and I'll see you in the next one. Bye.